This video is all about ArcPy List Functions. Lists are an excellent way to iterate over several workspaces, feature classes and fields for example. This is extremely helpful if you wish to perform batch processing on multiple data sets or data elements. In this video we are going to look at several list functions with ArcPy. We're going to list workspaces, datasets, feature classes, which is probably the most common list you will use, tables, rasters, fields, another very common list function, and finally files and indexes. You are going to find this video slightly repetitive. No, it is going to be quite repetitive, but it is important to get familiar with lists. So up first is the list workspaces. The ArcPy List Workspaces function returns a list of workspaces from a current workspace. This means that we are required to have set the workspace environment setting property in our script. Returns a list of workspaces is important here. The function will always return a list. The syntax is arcpy.listWorkspaces, and there are two optional parameters, wildcard and workspace type, of which we will look at in this video. We will set our workspace property for our environment settings to our data folder. Let's pop over to ArcGIS Pro and take a look inside that data folder. I'm in our ArcPy 101 APRX, and over on the right hand side I'm going to expand on folders and expand on ArcPy 101 folder and then expand the data folder. Here we see the data folder has 4 subfolders: Excel, Other, Rasters and Shapefiles, and each of these folders is considered a workspace. Underneath these we have a series of file geodatabases, each a workspace of their own. In our first example we are going to call the ArcPy List Workspaces function, and we'll see that it returns every workspace that we see at this level in our data folder. We'll head back over to PyScripter. We will call the ArcPy.listWorkspaces function, and we are not going to supply any of the optional parameters. We'll assign the calling of the function to a variable called workspace list. List workspaces always returns a list, and will print the type of the workspace list variable to screen to show that it is of type list. We're then going to iterate through our workspace list and print each workspace to screen using the arcpy.addMessage function. Let's run the script. We can see that all our workspaces are printed to screen. First off, we can see the class list from printing the type of object our workspace list variable was. We see our folders, Excel, Other and Rasters, and down the bottom we have our shapefiles. Now yours might have printed out a bit different, but all the folder workspaces are there and accounted for. And sandwiched in between those we have our file geodatabase workspaces. Very interesting to note is that the full workspace path was returned for each list entry. It wasn't just the name of the workspace, it was the full path. We'll comment out our first example, and in our next example we are going to use the wildcard optional parameter. We have a few examples here to highlight the diversity of using the wildcard. The wildcard parameter takes a string. We can use an asterisk at the beginning of the string to represent 0 or more wildcard characters. For example, here we are placing the asterisk at the beginning of the string followed by a .gdb. In this instance, any workspace that ends in .gdb will be returned. In our next example, we can use an asterisk at the beginning and at the end to represent 0 or more wildcard characters. Here we place tpt in between an asterisk at the start and at the end. We will see that this returns only workspaces where tpt is consecutive within the name of the workspace. And of course we can use an asterisk at the end to represent 0 or more wildcard characters. Our example here, we use ref_bio followed by an asterisk. This will return any workspace where the name begins with ref_bio. The wildcard is not case sensitive, so we'll follow up that example where we use lowercase ref_bio to show that it returns the same list. And lastly, an empty list is returned if no wildcard match is found. We will supply in ref_arc sandwiched in between our asterisks, and we should see that an empty list is returned because we have no instance of a workspace where ref_arc is a substring. Let's run the script. Our script is complete. We can see for our asterisk.gdb, we were returned a list of all workspaces that ended in .gdb. For our TPT with an asterisk at the beginning and the end, we were returned our transport geodatabase, as it is the only workspace in the data folder that contains TPT consecutively. For ref_bio, we were returned a list that contained one file geodatabase, and that is because we only have one workspace where the name begins with ref_bio. We then tested with lowercase, and we can see we were returned the same as the previous example. The wildcard is not case sensitive. We also attempted to use a wildcard for ref_arc with an asterisk at the beginning and the end. There was no match found, so an empty list was returned. We'll comment out our examples for using the wildcard, and next we'll take a look at using the workspace type optional parameter. According to documentation, the workspace type parameter accepts access, coverage, file GDB, folder, SDE, and all, which is the default. In our first example, we are going to use a workspace type of file GDB, and in our second example, we're going to use a workspace type of folder. So we expect to see in the first example all our file geodatabases returned in the list, and in our second example, we should see all our folders, of which there are 4 of them. We'll run the script, and we can see that all our file geodatabases were returned from our first example. And for our folder example, we got our 4 folders returned from our data folder: Excel, other, rasters, and shapefiles. We'll comment out our workspace type example, and for our last example, we're going to combine the wildcard and workspace type optional parameters. In our first example, we'll look for any file geodatabase that has an _b in its name. And for our second example, we'll look for any folder that begins with shape. We'll run the script, and we can see in our first example, we look for any file geodatabase with _b. We will return 2, and both of these actually contain _b twice. That was our base mapping geodatabase and our biodiversity geodatabase. For a folder that begins with shape, we were returned 1 element in the list, and that is our shapefiles folder. We can see it begins with shape, and then the asterisk is a wildcard for 0 or more characters after the shape. It was important to note there that the ArcPy List Workspaces returned a list of workspaces with the full workspace paths. Up next is the ListDatasets ArcPy function. The ArcPy.ListDatasets function returns a list of datasets in the current workspace. The fact that it says here current workspace indicates that we require the arcpy.env.workspace to be set. Now this function will return an empty list if the workspace is anything other than a file or enterprise geodatabase, or if there's no dataset present. It'll also return an empty list. The syntax is arcpy.listDatasets, and it takes an optional wildcard, which is not case sensitive, as we'll see, and the feature type, which is the dataset type you are looking for. So let's take a look at the ListDatasets function in action. We're going to set our workspace environment setting to be our utilities geodatabase. So let's head over to ArcGIS Pro and check out that geodatabase to see the list of feature datasets that are currently within that workspace. So I'm back in the ArcPy 101 APRX, and on the right hand side we have our utilities geodatabase, and if we expand that workspace, we can see we have a selection of feature datasets. There are 6 of them in fact: BT, AIR, ENET, ESB, GNI and Virgin Media. We will use the utilities geodatabase and the feature datasets inside for use cases with the ArcPy List Datasets function. So let's head back over to PyScripter. In our first example, we are going to call the arcpy.listDatasets function and use no parameters. We'll assign this to a variable called dataset list. The ListDatasets function always returns a list, whether it's empty or not. We will print the type of our dataset list object to screen to see that it is a list. We will then iterate through our dataset list and print each dataset returned in our list to screen. We saw that there were 6 datasets in the utilities geodatabase. So let's run our script and see the output. We can see that the ArcPy List Datasets returned a list, and for each dataset in our list we were returned the name of the featured dataset. It is important to note here that we were simply returned the name, not the path to the dataset. We'll comment out the first example and we will open up the second example. In our second example, we are going to use the wildcard filter, and we're going to use it a number of times to return various different data sets from our utilities geodatabase. We can use an asterisk at the beginning of the wildcard string to represent 0 or more wildcard characters. So basically here we want any data set returned that ends with an M. We take a look below what was returned from our list datasets. We can see that Virgin Media here is the only one that ends in M, and that is what we're expecting to be returned from our first example with the wildcard. We can also use the asterisk at the beginning and at the end of the wildcard string to represent 0 or more wildcard characters. Here we will be returned any featured dataset, any dataset within the geodatabase that contains an N. If we look below again, we will expect Virgin Media, GNI and ENET to be returned. We can also use the asterisk at the end only to represent 0 or more wildcard characters. In this example, we are looking for any dataset that begins with EN. And again, if we look below, we should be returned ENET. We'll perform the same action, this time using lowercase characters, just to prove that the wildcard is not case sensitive. And for our last example with the wildcard, we will be returned an empty list as we use the wildcard filter where no match is found. So here we are going to look for any dataset that contains a Z, and we know from our list that there is no Z in any of our dataset names. So we expect an empty list to be returned here. So let's run the script and check the output. Here we see that we use the asterisk at the start of our wildcard string, indicating we are only interested in datasets that end in M. And we see that Virgin Media was the only one returned within the list. A list is always returned when using the list dataset function. We then use an N sandwiched in between 2 asterisks, indicating that as long as it had an N in the dataset name, it would be returned, and 3 were returned. We placed the asterisk at the end of a wildcard string, indicating that it must begin with EN, and we returned ENET. We did the same except with lowercase, just to show that the same is returned, that the wildcard is not case sensitive. And lastly, we searched for Z within our dataset names, and we returned an empty list because there was no match found. We'll comment out our second example, which used the wildcard, and we will look at using the feature type optional parameter. So we're going to filter by dataset type. We'll uncomment the example so we can talk through and run the script. So the feature type parameter accepts coverage, feature, which is for a featured dataset, geometric network, and so on. You might also quite often use raster. We're going to switch our workspace to be our base mapping geodatabase. And we're going to look to get a list of feature datasets and also raster datasets from our base mapping geodatabase. So let's head over to ArcGIS Pro and take a quick look inside that geodatabase. Here's our base mapping geodatabase. If we expand, we can see that we have one featured dataset for the OSI, and we have 3 raster ListDatasets. Let's head back over to PyScripter. We'll call the ListDatasets function, and we will use the feature type parameter and supply in feature, and we'll print that list to screen. So we expect that to return OSI. We'll then do the same for our raster datasets, which we saw there were 3. So we expect 3 entries in our list returned when our feature type is raster. So let's run the script. And we can see for our feature datasets, we got our OSI returned in our list. And for our raster, we got all 3 rasters that were available in our geodatabase. We'll comment out the example for filtering by dataset type. And for our last example, we are going to use a combination of the wildcard and the dataset type. Here we are looking for any dataset that contains the letter N and is a feature dataset. We have gone back to our utilities dataset because we've commented out base mapping, and up the top here we are accessing our utilities geodatabase. We'll run the script, and we were returned 3 feature datasets that matched our wildcard string. We've now seen 2 ArcPy list functions in action, the ListWorkspaces and the ListDatasets. The ListWorkspaces returned the full path to the workspace, where the ListDatasets just returned the dataset name. Up next is one of the main events, and is the ListFeatureClasses function with ArcPy. The ArcPy ListFeatureClasses function returns a list of feature classes in the current workspace. Current workspace here is important. This means that we require the arcpy.env.workspace to be set. Also important is that the function will always return a list. The syntax for the ListFeatureClasses function can be seen here, and there are 3 optional parameters: a wildcard, a feature type, and a feature dataset. We've seen the wildcard in the previous 2 videos, and we'll see it again here. Feature type is the type of feature class itself, so you could have point, polyline, polygon, annotation, and so on. Or if we need to access a feature dataset to retrieve a list of feature classes within that feature dataset. A feature dataset can only store feature classes. We will use our hydrology geodatabase as our workspace. So let's pop on over to ArcGIS Pro and have a look inside that hydrology geodatabase. I'll collapse base mapping and utilities and expand hydrology. And we can see here that there is 1 feature dataset for the EPA, and this contains 3 feature classes for canals, lakes and rivers. At the root level of our geodatabase, we have 3 tables. We will be using the ListTables in the next video. For now, we are concerned about these 3 feature classes here from the Geological Survey of Ireland. So we have 3 feature classes at the root level of the hydrology geodatabase, and also 3 feature classes in our EPA feature dataset within our hydrology geodatabase. So let's head back to PyScripter and take a look at the ListFeatureClasses function in action. In our first example, we are going to list all the feature classes in a file geodatabase, and that is our hydrology geodatabase. We'll call the arcpy.listFeatureClasses function without supplying in any parameters, and we'll assign the calling of the function to a variable called fc_list. We'll print the type of that fc list variable to the screen. We will see that it is a list object. We will then iterate through our fc list and print each feature class within our list to screen. So let's run the code. So we can see that the list feature classes returned a list object, and within that list we had 3 feature classes. Now what do you notice? It only returned the 3 feature classes from the root level of our hydrology geodatabase. It did not step inside the feature dataset, which we saw there was an EPA feature dataset that also contained 3 feature classes. Another thing to note is that it only returned the names of the feature classes themselves and not the full file path. We'll comment out these two lines of code here where we list our feature classes in our geodatabase and where we print the type of the feature class list variable to screen. And we'll uncomment these two lines of code here and we'll look at listing all feature classes in a folder. Here we're going to set our workspace environment to be our shapefiles folder in our data folder. We'll then call the ArcPy.ListFeatureClasses function without providing any parameters. And once again, assign it to a variable called fcList. We'll then iterate through that list and print each feature class to screen. So let's head to our shapefiles folder and see what shapefiles we are expected to be returned. We'll head back to ArcGIS Pro. You can see here we have our shapefiles folder, which we will expand, and we have 7 shapefiles in here, 3 from the EPA, 2 from the MPWS, and 2 from the National Transport Association. So we expect to see 7 feature classes returned when we run our script and the names printed to screen. So let's head back to PyScripter and see if that is the case. We'll run our code. We can see we did indeed get all 7 shapefiles returned, and interesting to note, it also included the .shp file extension. Comment out our code from our first example and we will open up the code for our second example where we are going through the use of the wildcard filter. We can use the asterisk at the beginning to represent 0 or more wildcard characters. So here we are looking for any feature classes that end in _ply, and this has gone back into our hydrology geodatabase. If we take a look at a previous printout, we are expecting 2 to be returned: groundwater vulnerability and groundwater recharge. We can also use the asterisk at the beginning and the end to represent 0 or more wildcard characters. So in our example here, we are looking for any feature class that contains the name wells. And if we look back to what was returned, we can see that wells 10 to 50 meter accuracy should be returned in a list for that example. We can also use the asterisk just at the end of the wildcard string. Here we are looking for any feature classes that begin with GSI_HYD_G. And if we take a look below, we can see that that will also return 2 feature class names. The wildcard is not case sensitive, so we will use lowercase GSI_HYD_G and see that it returns the same as the previous example with the uppercase. We'll then provide an example that returns an empty string where no wildcard match is found. Here we are looking for any feature class that contains GEO consecutively, and if we look at our 3 feature classes, we can see none of them have that matching substring. So we expect an empty list to be returned. So let's run the script and check our output. We can see here for the feature classes that end in _poly, we returned a list containing 2 entries. For any feature class that contained the word wells, we can see we got 1 returned in our list. We then looked for feature classes that begin with GSI_HYD_G, and we can see that 2 were returned. And just to show that the wildcard filter was not case sensitive, we performed the same wildcard search or filter using lowercase characters, and we will return the same as above. We then attempted to find any feature class in our hydrology geodatabase that contained GEO consecutively, and there was no matches found, so we were returned an empty list. Comment out our second example there where we used the wildcard optional parameter, and we're going to use the feature type parameter in our next example. So here we are calling the ListFeatureClasses function and using the feature type optional parameter and supplying in polygon. So we'll be only returned feature classes that are of polygon shape type. We will also do the same for point. And if we head back over to ArcGIS Pro and into our hydrology geodatabase, we can see that we have 2 polygon feature classes and 1 point. So we expect 2 polygons to be returned in the first list feature classes and 1 point feature class in the second code snippet. So let's head back to PyScripter and we'll run the code. You can see here we got our 2 polygon feature class names returned and our 1 point feature class returned. We'll comment out our feature type example and we'll take a look at filtering by wildcard and feature type. So we're going to use 2 optional parameters here, the wildcard and the feature type. So here we're going to call the ListFeatureClasses function and use the wildcard parameter, and we're going to look for any feature class that contains the word recharge, and we want to limit the return to only those feature classes that are of polygon shape type. If we look below, we have one called groundwater recharge, and this is the only one we're expected to be returned. We'll run the script and we can see that our list feature classes returned 1 entry in our list that contained the word recharge and was of type polygon. We have a couple of more examples to go. We'll comment out that example 4, and open up example 5, where we are returning feature classes from a specific feature dataset. So here we're going to call the ListFeatureClasses function, and we're going to use the feature dataset optional parameter and supply in the EPA, which represents the feature dataset in our workspace. And we saw previously that this should return 3 feature classes. So we'll run the script and we can see that's exactly what was returned: our rivers, lakes and canals feature classes in our EPA feature dataset. We'll move on to the last example for this video, and that is where we are going to return feature classes from a specific feature dataset using the wildcard and the feature type parameters. So we're going to use all 3 optional parameters in this example. We'll set our wildcard where we want any feature class that contains the word canal. Now the feature type must be a polyline, and we are searching within our EPA feature dataset. And if we look below, we have one matching return, which is canals, which is a polyline and is in the EPA feature dataset. So we'll run the script and we can see we have returned our single feature class that matches all the filters set using the ListFeatureClasses function. You can see the common theme across all the list functions so far. They all return a list of something: workspaces, datasets, feature classes. They all have their subtle differences. With the ArcPy.ListWorkspaces, we did not have to set the workspace environment setting, but we did for the dataset and the feature classes. Up next is the ListTables function. The ArcPy ListTables function returns a list of tables in the current workspace. Let's break that down. The ListTables function will always return a list, and that is a list containing none, one or more tables. The tables returned are from the current workspace. This indicates that in order for a successful run of the ListTables function, that the arcpy.env.workspace has to be set. You can see the syntax here: arcpy.listtables, and there are 2 optional parameters, a wildcard and a table type. The wildcard we have seen in the previous few videos in this section, and the table type limits the list returned by the function to a certain table type, such as a dbase table or a .info, and we'll take a look at this towards the end of this lesson. In the previous video, we used our hydrology geodatabase as our workspace for the ArcPy List FeatureClasses function, and we will do the same for the ArcPy List Tables function. We know that there are 3 tables in that geodatabase. Let's head over to ArcGIS Pro for a little recap. Here we have our hydrology geodatabase, and here we have our 3 tables: our canal, groundwater and surface water status tables. Let's head back over to PyScripter and assess the ListTables function with ArcPy. In our first example, we will list all tables in that hydrology geodatabase. We will call the ListTables function and supply no parameters and assign it to a variable called table list. We will then print that table list to screen. So let's run our script. And we can see that our 3 tables were returned. Just to note, it was simply the name of each table and not the full file path to each table. We can also use a folder as a workspace. So in this example here, we are going to use our Excel folder in our data folder as our designated workspace. We'll then call the ListTables function, providing no parameters, and set it to the variable table list, and then print that list to screen. Let's head over to ArcGIS Pro and have a little look inside this Excel folder. We have our Excel folder up the top here. We'll expand, and we can see that we have 3 XLSX files and 2 CSV files. So it will be interesting to see which of these files the ArcPy List Tables returns, or does it return them all. We'll head back over to PyScripter and check it out. Let's run our script. And we can see that we were only returned the CSV files from that folder. ArcPy did not recognize the XLX files as tables, and this is because they're not tables. Each sheet inside an Excel file represents the table. We'll comment out our first example, and in our second example we will go through the wildcard optional parameter with the ListTables function. We can use an asterisk at the beginning of a wildcard string to represent 0 or more wildcard characters. So here we use the wildcard parameter and we supply in an asterisk at the beginning of our string. This means that only tables that end in surface water underscore table will be returned by the ListTables function. If we look below, we can see that this wildcard matches one of our tables, and that is EPA hide surface water status table. We can also use an asterisk at the beginning and the end of the string to represent 0 or more wildcard characters. In this example, we are looking for any table that contains the word canal. And again, if we look down below, we should have one table returned in our list, EPA hide canal water status table. You can of course just use the asterisk at the end to represent 0 or more wildcard characters. This means that when you provide the string, it must begin with that string. So here we are looking for any table that begins with EPA hide ground. And if we look below, we will simply get the one return for our groundwater status. We'll run again, but this time we will use all lowercase for EPA hide ground to show that the wildcard is not case sensitive. And lastly, we are going to search for any table that contains ponds, which we do not have in our workspace. So this will return an empty list. Let's run the script and check the output. So we can see that for our surface water status table, at the end of a table name, we will return 1, and that is represented here in this list. For any table that contained canal in our workspace, we were returned 1 table in a list. And for our EPA hide ground at the start of any table, we got our groundwater status returned in the list. And just to show that the wildcard filter is not case sensitive, we used all lowercase and got returned the same as above. We then attempted to find any table that contained ponds. No table in our workspace contained ponds, so we were returned an empty list. Comment out example 2 using the wildcard filter, and we will take a look at using the table type parameter. In our first example in this section, we're going to set our workspace to be our other folder. And we want to list tables that are of a table type DBase. If I go back into ArcGIS Pro and go to our other folder, we can see we have one DBF file in that folder. We'll head back over to ArcPy and run the script. and we can see that our DBF file was returned in a list. Now, interestingly, a shapefile contains a DBF file. Let's comment out our example and open up the second part of the table type example. And here we are looking in our shapefiles folder. This will be our workspace. And we're going to attempt to call the ListTables function and set a table type to dbase. Now let's open up our shapefiles folder from the Windows File Explorer. Here I'm in the ArcPy 101 folder on the C drive, and I'm going to go into data and into shapefiles. And we can see here that each of our shapefiles has a .dbf file. Let's go back and run our script to see the output. And we can see here that we were returned an empty list. So yes, you can get dbase tables using the ListTables function, but they need to be standalone dbase files. Using the ListTables function to list dbase tables that are associated with shapefiles returns an empty list, or that those dbase tables associated with the shapefiles are simply not considered as tables by the ListTables function. We just saw the ListTables function in action with some nuances, that it doesn't pick up Excel files but it did CSVs, and that it picks up DBF files when they are standalone in a folder but not when they are associated with shapefiles. Up next is the ListRasters function. The ArcPy.ListRasters function returns a list of rasters in the current workspace. The function will always return a list containing none, one, or many rasters. Also important to note that it returns a list of rasters from the current workspace. This is because the ArcPy.ListRasters function requires ArcPy.m.workspace to be set. Here we have the syntax for the ListRasters function. There are two optional parameters, a wildcard and a raster type. We are going to set our workspace environment setting to point to our base mapping geodatabase. Now let's head over to ArcGIS Pro and take a look inside that geodatabase. I'll collapse some of these open folders and geodatabase. I'm going to open up and expand the base mapping geodatabase. Here at the root level we can see 3 raster datasets. We have one from the NASA Shuttle Radar Topography mission and 2 from Natural Earth. You also see that there is a featured dataset within this base mapping geodatabase, but that contains a feature class. A feature dataset can only contain feature classes. So we are really interested in these 3 rasters in our base mapping geodatabase. Let's head back over to PyScripter and check out the ListRasters function. We'll first list all rasters in our file geodatabase. We will call the ListRasters function and supply no parameters and assign that to a variable called rastList. We'll then print that list to screen to see that a list was returned, and we'll check out the contents of that list. So let's run the script. We can see that our 3 rasters were returned in the list, and interesting to note, it was the name of each raster and not the full file path. We'll comment out that code snippet that we just ran, and we'll open up a second one here where the workspace is a folder. So here we're setting our workspace environment setting to be the rasters folder in our data directory. We're then going to call the ListRasters function and assign it to a variable which will return a list, and we'll then print that list to screen. So let's head back over to ArcGIS Pro and check out this rasters folder. We'll expand our rasters folder, and we can see in here we have 4 rasters. We have 3 .hgt files from the Shuttle Radar Topography mission, and we also have a TIFF from Natural Earth. Let's head back over to PyScripter and run our script. And we can see that all 4 of our rasters have been returned. And just interesting to note this time is that the file extensions are also returned along with the name of the raster. We'll comment out the first example and we are going to move on to our second example where we use the wildcard optional parameter to filter what is returned in our list when we call the ListRasters function. We can use an asterisk at the beginning of a wildcard string to represent 0 or more wildcard characters. Here where we place the asterisk at the start, the rasters returned in the list must end in srtm_rst. We can also place the asterisk at the beginning and the end to represent 0 or more wildcard characters. In this instance, where you use both at the start and the end, it will return any rasters that contain the substring. So anything that contains GE will be returned. You can also just place the asterisk at the start. This means that the raster name must begin with the string. Here we're looking for any raster that begins with NASA. And just to show that the wildcard is not case sensitive, we will also put NASA as lowercase. We will call the ListRasters function and use the wildcard optional parameter and supply in where we're looking for any raster dataset that contains OSM. Now if you think back to the list of rasters that we saw, none contained OSM, so we'd expect an empty list returned for this example. So let's run our script and check the output. So here we can see when we were looking for srtm_rst as the last characters to be matched in a raster dataset, we can see we returned 1 in our list from our shuttle radar topography mission. We then searched for any dataset, any raster dataset that contained the substring GE, and we were returned 2. We can see here that drainage here has a GE and also on this one here. In fact, the second one here has 2 GEs. And you might be thinking, why was this one returned with a lowercase GE? It is because the wildcard is not case sensitive, as we're going to see from the next 2 examples. We looked for NASA with uppercase at the start of the name of our raster datasets, and we got 1 returned. And then we also used lowercase and we got the same one returned. So the wildcard optional parameter is not case sensitive. We tried to find any raster dataset in our workspace that contained OSM. None were found, so we returned an empty list. So it's important to note that the ListRasters function will always return a list. Same with any of the list functions. We will comment out our second example where we use the wildcard filter, and we will take a look at the next example where we filter by raster type. In our first example here, we are going to use the ListRasters function and the raster type optional parameter, and we're going to look for only rasters that are of grid type. We can see here that the raster type parameter accepts these options here, but I'm going to show you that that's not all they accept. So this first ListRasters function is looking in our base mapping geodatabase. We are then going to switch to our rasters folder where we saw there were 3 HGT files and 1 TIFF file. We will isolate the TIFF file and we will isolate the HGT files. Now as you can see here, I'm calling the raster type and supplying in HGT, which is the extension for those files, but that is not in the documentation, so you can actually add in other extensions to search for. So let's run our script and check the output. So you can see for our first output where we're looking for grid in our base mapping geodatabase, all 3 of our rasters were returned. So all 3 of these were of grid type. We then switched to our rasters folder where we wanted to look for TIFF files, and we got 1 returned as a matching for a TIFF file. And then we looked for our HGT files and all 3 were returned from our ListRasters function. We'll comment out that example and we'll check the last example where we use the wildcard and raster type optional parameters. Here we are going to look in our rasters folder, so that will be our workspace. We will then call the ListRasters function and use the wildcard parameter, supplying in an asterisk at the start and at the end, and we're looking for any raster that contains W009, and the raster type must be of HGT. Now if we look below, we can see that one of these match that criteria. So let's run our script and check the output. And we can see that we were returned our single raster in our list. Okay, time to move on to something slightly different. So far you've been looking at workspaces and datasets and feature classes. Now we're going to dig into an actual feature class and list the fields. So up next is the ArcPy List Fields function. The ArcPy.listFields function returns a list of field objects in a feature class, shapefile, or table. Just like the previous listing functions in ArcPy, a list is always returned. The important thing to note here is that the ListFields returns a list of field objects. And we're going to see this when we run our first example. The syntax is ArcPy.listFields, and as stated, it does have one required parameter, and that is dataset, and it also has two optional parameters, a wildcard and a fields type to limit the return to. For the following examples, we are going to use our bird reserves feature class from our biodiversity geodatabase. So let's pop on over to ArcGIS Pro and have a look at the fields within the bird reserves feature class. I'll collapse the rasters folder and the base mapping geodatabase and expand the biodiversity geodatabase. We have here our RSPB feature dataset, and in there we have our bird reserves feature class. I'm going to right click and go to data design and select fields. This will open up the fields view for the bird reserves feature class. We can see here we have our field names and our data type. The ones grayed out here are system maintained fields, object ID, shape, shape length, shape area, and global ID, and their associated data types of object ID, geometry, double, and global ID. We then have the user defined fields. We have feature ID as a long, name, sensitive, type, access as text fields, and last update as a date. So let's head back over to PyScripter and check out the ListFields function. We'll set the file path to our bird reserves feature class to a variable called FC, which just stands for feature class. We'll first list all the field objects for our bird reserves feature class. We'll call the ListFields function and set the dataset to be our bird reserves feature class, and we'll assign the calling of the function to a variable called field list, and we'll print that field list to screen. So let's run the script. Now you might have been expecting field names to be populated in our return list, but remember, it does say returns a list of field objects. So let's take a look. We can see here that the list returned is a list of field objects. Now, while each object here represents each field that we saw in the feature class, it is very hard to discern which one is associated with object ID, global ID, or any of the other fields in the feature class. We'll comment out that code snippet and we'll open up the next one. Here we're going to return a list of field names in our list rather than field objects. Each field object has a name property. Now, while we will look at field objects in more detail in a later section, just trust me on this for now that there is a name property for a field object where we can get the name of the field. We'll create an empty list called field lists. We're then going to iterate through the list that is returned from the ListFields function. We're then going to append into our empty list the name for each field in our feature class. We will then print that list to screen. The following two lines of code do the exact same thing, except they use a more efficient route by utilizing list comprehension in Python. Now, if you do not know what list comprehension is, I urge you to check it out. It is a slick and efficient way to perform multiple lines of code in one single line of code when we are talking about for loops. So here we use 4 lines of code, and here we're going to use 2 lines of code to perform the same actions. If we read this list comprehension here, we're saying for each field returned in our ArcPy list fields, which we know are field objects, So for each field object, we want the field.name returned in our list, and list comprehension will always return a list. So let's run the script and see the output. We can see that each code snippet returned the same output. We got a list of our field names from our bird reserves feature class. Comment out those code snippets, and we'll do one more in this example where we are going to look at the fields for a shapefile. We're going to set a variable called shp to point to the file path to our bus errand routes, which is a shapefile that sits in our shapefiles folder. So let's head back over to ArcGIS Pro and just take a look at those fields. I'll expand the shapefiles folder and right click on bus errand routes and go to data design fields to open up the fields view for the bus errand routes shapefile. We can see here we have 19 fields. I won't run through them all, but when we call the ListFields function on our bus errand routes, we are expecting 19 fields returned. That is 19 field objects. We will get the name of each of those objects that represents the field name. So let's head back over to PyScripter. We'll call our ListFields function and set our dataset to be our shapefile. We'll then print that field list to screen, which will be a list of field objects. We'll then use the list comprehension to get the name of each field and produce a second list that shows the name for each. So let's run the script. And we can see that our first field list contains all of the field objects, and our second list return has the name of each field in our bus errand routes shapefile. Comment out that example, and next we will take a look at using a wildcard filter. We've seen the wildcard filter in all the previous listing functions so far. We can use an asterisk at the beginning of a wildcard string using the wildcard optional parameter to represent 0 or more wildcard characters. Here we are looking for any field that ends in ID from our feature class, which is our bird reserves feature class. We will print the field list to screen, and that will be a list of field objects. And I want to drive this home that it always returns a list of field objects. We will then perform a similar action, and we will use field comprehension, and we'll get the name of each field returned. You can also use an asterisk at the beginning and the end of the wildcard string. Each asterisk represents 0 or more wildcard characters. In this instance, we are looking for any field that contains an underscore in our bird reserves feature class. We will print the list of field objects returned, and we'll print the name of each field returned also. We can also use the asterisk at the end of the string just to represent 0 or more wildcard characters. So here we're looking for any field in our bird reserves that begins with the word last. We'll print the objects to screen and the field names returned. The wildcard is not case sensitive, so I'll perform the same action as we did in the previous code snippets, except we're going to use all uppercase characters. Again, we're looking for any field that begins with last. And for the last example in our wildcard, we're going to look for a field name that contains the word field. Now, if we think back to our bird reserves, there was no field that contained the word field, so we expect this to return an empty list. Let's run the script and check the output. You can see here that when we looked for a field that ended with ID, that 3 were returned. We can see 3 field objects in this list. And then from our list comprehension, where we return the name of each field, we can get the name of each field: object ID, global ID, and feature ID. And we can see that they all end in ID. Feature ID was returned here, even though it has a lowercase d, because the wildcard filter is not case sensitive. We then looked for any field that contained an underscore, and 2 field objects were returned, and that was shape underscore length and shape underscore area. Then looked for any field that began with the word last, and there was 1 found, and that was last update. And we tested the wildcard character case sensitivity by supplying in last in all uppercase, and the same was returned as above when we used title case. And this shows that the wildcard is not case sensitive as we got the same output returned. We then tried to find a field that contained the word field. There was none present, so we returned an empty list. We'll comment out our second example where we showed details about the wildcard filter, and we'll check out the next example where we filter by field type. Here we are calling the ArcPy List function, and we are assigning it to a variable called field list. We are using our bird reserves feature class, and we only want fields returned where they are of type string. Now the field type parameter accepts this list of data types up here, and that if we don't set the field type, it is all by default. We'll print the field objects returned when we set the field type to string, and we'll also use list comprehension to get the name of each field that is of field type string. We will then repeat that for where the field is type OID. We expect 1 to be returned because a table can only have one object ID field set. So let's run the script. We can see when we were looking for field type string that 4 were returned, and we can see the names of those are name, sensitive, type and access. And we can see when we looked for the OID field type that 1 was returned, and that was our object ID. We'll comment out that example. And for our last example, we're going to filter by wildcard and field type. So here we're calling the ArcPy List function. Our data set is our bird reserves feature class. We're going to set a wildcard to look for a field that ends in update, and that field type must be of type date. We'll assign the calling of the function to a variable called field list and print at the screen, which will return a list of field objects. We'll then use our list comprehension and extract the field name for each field object returned and return that as a list also. So let's run the script. And we can see that one field object was returned and the name of that field was last update. Well, that was a little bit different. You saw there with the ArcPy.listFields function that a list of field objects were returned, and that you had to dig into the properties of each object to return the name for each field. Up next, we have the ArcPy.listFiles function. The ArcPy ListFiles function returns a list of files in the current workspace. We're going to see that it returns a list of file names, and that we see here from the current workspace. This indicates that the ListFiles does require the arcpy.m.workspace to be set. Here we see the syntax, which is arcpy.listFiles. There are no required parameters, and there is one optional parameter, the wildcard. We'll start by listing all files in our workspace by using the ListFiles function without the optional parameter. We're going to set our workspace to be our data folder. We're going to call the ListFiles function and assign it to a variable called file list. We'll then print that file list to screen. Now let's take a look at this data folder. Here I am in the ArcPy 101 folder on my C drive. I'm going into data. We can see here we have some folders, Excel, other rasters, and down the bottom is shapefiles. And we also have a selection of file geodatabases that are folder based. Let's go back into PyScripter and run our script. So we can see that even though we didn't have files in there, we did have folders, and each folder was returned, and the name of all our geodatabases were also returned. Important to note, it was simply the names of the folders and the names of the geodatabases returned, and not the full paths. If we compare that to the running of the ListWorkspaces, which we will run now, we'll set our workspace environment to be our data folder, and then we're going to call the ListWorkspaces function and print those workspaces to screen. So we'll run the script, and we can see that with the ListWorkspaces we get the full path to each workspace, whereas with the ListFiles we are only getting the names. Comment out that code snippet and the workspace for our data folder, and we're going to take a look inside our transport geodatabase folder, and we're going to look to list the files inside that geodatabase folder. So here we are setting our workspace environment to be our transport geodatabase. We're going to call the ListFiles function and assign that to a variable called file list, and then we'll print that file list to screen. Now let's reopen our Windows Explorer and take a look inside that transport geodatabase. Here I'm going to click into the transport.gdb, and we can see all these files that make up a file geodatabase. We'll go back to PyScripter and run, and we can see that we got returned all those files. So it's important to note that when you set the workspace to be a file geodatabase, it is not looking for files as in feature classes. It is going to access the files that make up that geodatabase. Comment out the first example, and in our next example we're going to use the wildcard filter that we've seen with the other list functions. We can use the asterisk at the beginning of the wildcard string to represent 0 or more wildcard characters. We're going to set our workspace here to be our Excel folder in our data directory. I'm going to look for any files that end in .csv. We will also look in the same Excel folder for any files that contain the word catalog. So here we're using the asterisk at the beginning and the end of the wildcard string to represent 0 or more wild characters. So let's open up that Excel folder and have a look at the files inside. Click back up and into our Excel folder. And here we can see that we have 2 CSV files that we expect to be returned when we're looking for file names that end in .csv. And we have one file here, an XLSX file that contains the word catalog. I'll head back into PyScripter. We're then going to shift our workspace to be our shapefile folder in our data directory. And we're going to use the asterisk at the end of the wildcard string to represent 0 or more wildcard characters. And we're going to look for any file in our shapefiles folder that begins with NTA. We're going to repeat a similar code snippet. This time we're going to use a lowercase NTA just to show that the wildcard is not case sensitive, and it will return the same as the code snippet above. And lastly, we will search inside our shapefile folder using the ListFiles function and look for any file that begins with FDM. Now I know that this will return an empty list because no file in that folder begins with FDM, but let's take a look inside our shapefiles folder and have a look. Click back up, scroll down into shapefiles. So we're looking for anything that begins with NTA. We can see down here we have 2 shapefiles. So there's 8 files here making up those 2 shapefiles. And we're also looking for any file that begins with FDM, and we can see that that does not exist. So I'll head back to PyScripter and run the script. You can see here when we were looking in our Excel folder for anything that ends in .csv, we were returned 2 file names, and they were returned in a list. We also looked for any file in our Excel folder that contained the word catalog, and one was returned, our data catalog XLSX. We then set our attention on the shapefile folder, and we looked for any file that began with NTA. That is an error there, that asterisk was not actually used. And we can see that we returned 8 files that make up our 2 shapefiles that begin with NTA. We then ran the same code snippet, except we looked for lowercase NTA, and just to show that the wildcard is not case sensitive, we can see that the same output was returned. We then looked in our shapefile folder for any files that began with FDM, and there was none, so an empty list was returned. You have learned a lot about the list functions with ArcPy. We have one left in this video, and that is the list indexes. The ArcPy.list ListIndexes function returns a list of indexes in a feature class, shapefile, or table in a dataset. Just to note that the ListIndexes returns a list of index objects. Similar to with ListFields, where we saw field objects, the ListIndexes returns index objects. You can see the syntax here. It is arcpy.listIndexes. There is one required parameter, and that is a dataset, and there's an optional parameter of wildcard. For the following examples, we are going to use our rivers feature class in our hydrology geodatabase. Let's head over to ArcGIS Pro and have a look at our rivers feature class. I'm going to close down any field views that are currently open, collapse the shapefiles folder and the biodiversity geodatabase, and expand the hydrology geodatabase. And into the EPA feature dataset, we have our rivers feature class. I'm going to right click and I'm going to open the table for the rivers feature class. Here we have the table for our rivers feature class. If you take a look at any field that has an asterisk beside it, it'll have an index. If you look at object ID, we can see it is indexed. It says index yes. If I take a look at name, index no. Go back to shape that has an asterisk, indexed yes. EU_CD is indexed. If we scroll across, if there was any other field that had an index, it would have an asterisk, but there are no other fields with an asterisk. So there are no other fields that contain an index. So when we list our indexes for this feature class, we are expecting 1, 2, 3 to be returned. Let's head back to PyScripter and check out the ListIndexes function. We'll assign our rivers feature class to a variable called FC, which just stands for feature class. We'll then call the arcpy.listIndexes function, and we'll set our dataset parameter to be our rivers feature class. We'll assign the calling of the function to a variable called indexList. We'll then print that index list to screen. As mentioned, we are expecting index objects to be returned, and we should see 3 of them from the 3 fields that we saw had an asterisk in our attribute table. So let's run the script. And we can see that we returned a list that contains 3 index objects. This is what we were expecting. Let's comment out that example and open up this example here, where we're going to use list comprehension and return the names of the indexes. An index object has a name property. So for each index object that is returned by our ListIndexes function on our rivers feature class, we want the index name returned in the list, and we'll print that list to screen. So let's run the script, and we can see that we got 3 returned in our list: FDO_object ID, FDO_shape, and FDO_EU_CD. They represent the 3 names assigned to our indexes. We'll comment out our first example, and we'll open up our second example where we use the optional wildcard parameter. We use an asterisk at the beginning of a wildcard string to represent 0 or more wildcard characters. Here we are calling the ListIndexes function, and we're using our rivers feature class, and we're setting a wildcard parameter as an asterisk ID. Here we want to return any indexes that end in ID. And if we take a look below, we can see that 1 fits this criteria, and that is our FDO_object ID. We will then print the list return to screen. We expect this to contain 1 index object. We're then going to use list comprehension to return the name of the index or any indexes returned, and we'll do this for each example below. We can also use an asterisk at the beginning and the end of the string to represent 0 more wildcard characters. In this example, we are looking for any index that contains an underscore, and really that'll be all 3 of them. We can also use the asterisk at the end of the string to represent 0 or more wildcard characters. Here we are looking for any index that begins with FDO_S. And if we look below, we can see that the FDO_shape is the only one that satisfies that criteria. The wildcard is not case sensitive, so we'll run the above code snippet again, but this time with lowercase FDO_S to see that it returns the same as the snippet above. We'll then run the ListIndexes function one last time. This time we're looking for any index name that contains the word index. And if we look below, we can see that there are none that satisfy this criteria, so we're expecting an empty list to be returned. So let's run our script and check the output. In our first example with the wildcard parameter, we looked for any index that ended with ID, and we got one object returned, and we can see the name of that was FDO_object_ID. We then looked for any index that contained an underscore. All three of our indexes in our feature class contained an underscore, so 3 objects were returned and all 3 names can be seen here. We looked for indexes that began with FDO_S. One index object was returned in our list, and we can see the name of that was FDO_shape. We also showed that the wildcard filter is not case sensitive, so we use FDO_S all lowercase, and we returned the same as the example above with one index object and the FDO shape. We then attempted to return any index that contained the word index, and that returned an empty list because the criteria was not satisfied because there is no matching index name. So we got an empty list returned. We'll comment out our wildcard examples and we'll take a look at the last example. Here is where we print some index properties. So we'll call our ListIndexes function and we'll use our rivers feature class. I will assign this to a variable called indexList. We're then going to iterate through each index object. So for each index object in our index list, we'll print the name of the index, we'll print the isAscending property, the isUnique property, and the fields. Now, this fields property returns a field object. So we can go and iterate through the fields that that index is associated with. So for each field in our index.fields, so in our field objects, we are going to return the field name. We saw in the ListFields video that a field object had a name property. So let's run our script. And we can see the name of our field, our FDO object ID. This field is in ascending order. It has unique values and is only associated with one field, and that is our object ID field. For FDO, ascending order is also true. It doesn't contain unique values, and the number of fields associated is 1, and that is our shape field. And lastly, we had our FDO_EU_CD. This index is in ascending order, does not have unique values. It is associated with one field, and that is the EU_CD field. Now, if you want to find out more about the ListIndexes function and also the index object, you can use these 2 links here to check out the documentation. That was a lot of listening with ArcPy. This video is here to act as learning material and also a point of reference to come back to. Make sure to check out more from the playlist and subscribe. Take care.